Everyone, welcome back. We solve for the value of x given this math problem. We have x cubed minus x squared. This is equal to 648. So what is the value of x? Solution. So we have x cubed minus x squared. This is equal to 648. Okay, so we can take this 648 on the left hand side, so that we'll have x cubed minus x squared minus 648. This is equal to 0. Okay, so we can express this 648 as x cubed minus x squared minus, now this is the same as saying 729 minus 81, which is equal to 0. Okay, so we'll have x cubed minus x squared. Now this is 729 can also be rewritten as 9 cubed minus 9 squared, because 9 squared is equal to 81 and 9 cubed is equal to 729. Okay, this is equal to 0. All right, so that we'll have x cubed minus x squared minus 9 cubed plus 9 squared. This is equal to 0. Okay, so that we'll have x cubed minus 9 cubed plus x squared minus 9 squared, and this is equal to 0. Okay, so that the first part is the difference of cubed expressed as a cubed minus b cubed, and the second part is the difference of two squares expressed as a squared minus b squared. Okay, cubes, which is expressed as a cubed minus b cubed, and the second part is the difference of two squares expressed as a squared minus b squared. All right, so that we'll have a cubed minus b cubed. This is equal to a minus b, a squared plus ab plus b squared. All right, so that now we have x cubed minus 9 cubed. Okay, this is going to give us x minus 9. Then here you'll have x squared plus 9x plus 81. That is now this we have x minus 9, x squared plus 9x plus 81. Okay, the second part, we have the difference of two squares. We have a squared minus b squared. This is equal to a minus b then a plus b. Okay, now we have the values as x squared minus 9 squared. This is expressed as x minus 9. We have those two terms, and x plus 9. Okay, is expressed as x minus 9 and x plus 9. So now we combine this part of x cubed minus 9 cubed and x squared minus 9 squared. We just recombine as follows. We're going to have x minus 9 x squared plus 9x plus 81 plus x minus 9 x plus 9. This is equal to 0. All right, so that since x minus 9 is common, we factor out x minus 9 as follows. X minus 9 will have x squared plus 9x plus 81 plus x plus 9. This is equal to 0. All right, okay, we have x minus 9 into bracket x squared plus 9x plus 81 plus x plus 9 is equal to 0. So clearly you can see that the first part will have x minus 9. This is equal to 0. So that means that our real roots is equal to, that means that x is equal to 9. So our real roots, the first is the real root is equal to 9. But now we have the other part, which is x squared plus 9x plus 81 plus x plus 9 is equal to 0. Okay, so that means that we have x squared plus 10x, okay, plus 90 is equal to 0. Okay, 9x plus x is 10x, 81 plus 9 is 90. Okay, so this forms a quadratic equation. This forms a quadratic equation. This forms a quadratic equation with a equal to 1, with b, that is the second term, equal to 10, and our c equal to 90. Okay, so the coefficient of x squared, which is a, is equal to 1, coefficient of x is equal to 10, and our constant is equal to 90. Okay, but now this quadratic equation has got what we call a discriminant value, which is less than 0. Okay, this discriminant value is expressed as b squared minus 4ac is less than 0. Okay, so that we'll have 10 squared minus 4 times 1 times 90. Okay, this is less than 0, so we'll have minus 260. Okay, minus 260, which is less than 0. So that's translate that, or that means we have two complex roots. We have two complex roots, or rather we have two imaginary roots. Okay, and these two imaginary roots are expressed in form of x1 and x2, which is equal to x1 is a plus ib, and x2 is equal to a minus ib. Okay, which are calculated as x1, x2, this is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. Okay, so we are using the quadratic formula. This is quadratic formula. Now this means that we'll have x1, x2, this is equal to minus 10 plus or minus the square root of 10 squared minus 4 times 1 times 90, divide everything by 2. Alright, so that we'll have minus 10 plus or minus the square root of, this is minus 260, minus 260, divided everything by 2. Okay, so this means that we'll have minus 10 divided by 2 plus or minus. Now, according to the complex identity rule, minus 1, this is equivalent to I. So minus 1 is equal to I. So we are going to express this as 260 I divided by 2. Alright, so this means x1, x2 is equal to negative 10 divided by 2. This is equal to minus 5. Okay, plus or minus. Now this is the square root of 260i divided by 2, which is equivalent to 8.062i. Okay, so this means that x1, which is our first imaginary root, which is equal to minus 5 plus 8.062i, and x2, this is equal to minus 5 minus 8.062i. So these are two imaginary roots that we have. Okay, but now remember we end the real roots, which is equal to x equal to 9. That is the real roots that we have. Okay, so we need to verify that x cubed minus x squared is equal to 648, given that the value of x is equal to 9. Okay, so we just substitute the value of x, so that we'll have this is x cubed minus x squared, which is equal to 9 cubed minus 9 squared. This is equal to 729 minus 81, and this is equal to 648. Okay, and this is our solution to this math problem. Thank you for watching, and those who have not subscribed, kindly subscribe. Thank you.